Hello everyone, we're going to be completing independent practice problems. Remember, I recommend using your math notebook and using your paper the normal way, which is called portrait. Please use a pencil, either number 2 or mechanical, and have an eraser handy. For the purposes of this video, I will be using a blank sheet of white paper and it will be in the landscape orientation. That is because it works better for the video camera. I'm also going to be using pen because it shows up better on camera. All right, let's get started. All right, in this video, we will be completing Module 1, Lesson 5, Independent Practice. Put your label at the top of your page and write your name. All right, number 1, and we do want to write the question, but we can shorten some of the words. So when for multiplying, when multiplying or dividing, and I'll just put div, when multiplying or dividing, integers, and those are whole numbers above and below 0. When multiplying or dividing integers with the same sign, the answer will be blank. All right, so we got to figure this out. So you can look back in the lesson or you can just write it out right here with me. If we multiply, let's just use ones. If we multiply positive 1 times positive 1, we get positive 1. If we multiply, right, we're looking at same sign. If we're looking at negative 1 times negative 1, our answer is going to be positive 1. A negative times a negative is positive. So in both of these situations, the answer will be positive. So that's our answer, positive. And to prove it, so that you get full points, you need to do a little proof right here by showing positive times positive is positive and negative times negative is positive. So that's how you show your work for this one, is you actually write out a little example. Okay, number 2. When multiplying or dividing integers with different signs, the answer will be blank. When or div, when multiplying or dividing, integers, integers with different, I'll put diff, with different signs, the answer is blank. All right, let's go ahead and do an example of this. So we have negative 1 times positive 1. So those are different signs, and we're going to get negative 1 as our answer. Let's reverse that and say we start with positive 1 and we multiply that by negative 1. We're going to get a negative 1. And I apologize for the little bit of background noise. That is my dog, who thinks right now is the perfect time to play. Okay, so we've got different signs is negative, different signs is negative. So that means the answer is negative. Okay, let's go ahead on to number 3. We're going to be solving this. So this is 6 times negative 7. All right, so one of the ways that you can do this is that you can say that you've got 6 multiples of negative 7. So here's how that would look. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. I'm using my number tiles. Remember the positives and negatives? So I've got 6 sets of negative 7. So there's 3. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. So 1, 2, 3, 4, 5, 6 sets of -7. And you could individually add all of these up. I know some of my multiples, 7, 14, and then 21, and then 28, and then 35, and then 42. So 6 times 7 would be 42, but 6 sets of -7 would be -42. Okay, let's do number 4. We have -96 divided by -6. So if we use our rule, a negative divided by a negative, our answer will be positive. So we'll keep that in mind here. 96 divided by 6. One way to kind of do this would be to actually use our number tiles and do however many sets of 96. So we could do this like 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. So 6, 12, 18, 24, 30, 36. So I'm up to 36 here. 42, 1, 2, 3, 4, 5, 6, 48, 1, 2, 3, 4, 5, 6. Wait. 48 times 2 is 96. Hold on, this is where we need an eraser. But 48 times 2 is 96. Do you see that? Do you see that number relationship? I'm not sure if you can see that. I can see that number relationship because I have a lot of experience working with integers. But let's think about it, okay? 40 times 2, 2 40s, 40 and 40 is 80, okay? And then 8 times 2, so 2 8s is 16, and if you put those together, we've got 96. So I'm adding 2 40s and 2 8s to get 96. This is how people do math in their head. They picture this kind of stuff in their head. So 48, 2 48s is 96. So all I have to do is double the groups I have here. Again, I totally need an eraser, don't mind that. So 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. So how many groups do I have? How many groups of 6? To get to a total of 96 pieces. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So that means that 96 divided into groups of 6, I've got 16 of them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So the answer is 16 groups. I love it when a plan comes together like that. All right, so that's how you can model division, is take your starting number and then divide it into groups. We do know that we have a negative divided by a negative, so our answer is going to be positive. All right, let's move on to number 5. -3 times -2 times -4. All right, let's just think about the negatives and positives real quick so we know if our answer is going to be negative or positive. So we have a negative times a negative. That would cancel out to be positive. And then a positive times a negative is going to be negative. So our overall answer is going to be negative. Now let's model this. If we have 3 negative sets of -2, that's like -2, -2, -2, right? And how many? 3 sets of -2. 1, 2, 3, 4, 5, 6. That's 6 of them. 6 pieces. And then because they're negative, they would multiply together to give us positives. So then we've got 4 of those. So okay, so now how many total do I have? If I have 4 sets of 3 sets of 2, that's kind of how multiplication works, right? You've got that many sets of that other thing. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. And we know our answer is going to be negative because we worked that out. So negative 24. Let's think about a different way to do this without drawing the model. So 3 times 2, we know that that equals 6, and we know it's going to be positive because negative times negative is positive. So that's positive 6. Positive 6 times 4 is 24. 6 times 4 is 24. And then we know that positive times negative is negative, so that would be 24. So you can work this out using different methods, okay? If you wanted to model this method right here, normally we would write it like negative 3 times negative 2 times negative 4, and we would show that this multiplies to be positive 6, and then we'd bring down this negative 4, so positive 6 times negative 4, and then those multiply together to be negative 24. And we kind of build a little upside down pyramid to solve that. So pick whichever way makes sense. Number 6. For problems 6 through 10, use positive and negative values to write a multiplication or division problem that models the question. Then find the answer. Okay, so number 6 says, while hiking down a hill, so let's draw a hill. We'll draw a mountain here. So our little guy, Devin here, we'll give him a backpack and some spiky hair. He's hiking down the hill. Okay, Devin noticed that the elevation dropped at the same rate for 5 minutes. Altogether, it dropped 15. So he's starting here and he's working his way down to here. And this was a total of 15 feet over the course of 5 minutes. Over 5 minutes. Need that eraser. Over 5 minutes. So we drop 15 feet over the course of 5 minutes. What integer represents the change in elevation each minute? Well, if we're 5 minutes, that means we're going to take 15 and divide it by 5 to see how it divides. So we've got 5, 1, 2, 3, 1, 2, 3, 4, 5, right? So if we're starting here and we're going here, 1, 2, 3, 4, 5. We've got 5 sections and together they equal 15. So what is each individual section worth? That's going to be 15 divided by 5. And can you do that in your head? Yep, it's 3. Okay. So 3 feet the first minute, 3 feet the second minute, 3 feet the third minute, 3 feet the fourth minute, 3 feet the fifth minute, and when we add all those 3's up, we get a total of 15. So here's our answer. 15 divided by 5 equals 3. All right, let's move on to number 7. I've got some Post-its here because I, again, am using pen so it shows up better on the camera, but I don't really like how I was modeling this problem, so I think there's going to be a better way to do it. So I'm going to start over. Number 7. Number 7 says, the price of 1 share of stock fell $1.30 each day for 5 days. So stock down $1.30 each day for 5 days. Okay, stock went down $1.30 each day for 5 days. What rational number represents the value one share of the stock lost after 5 days? So money lost after 5 days. Okay, so the stock went down $1.30 each day for 5 days. How much was lost after 5 days? So let's say total. Total money lost after 5 days. So we can represent this as, let's say we start at a certain point and we go 1, 2, 3, 4, 5 days. And we're going down. And we're going down $1.30. We're going down $1.30. We're going down $1.30. Down $1.30. Down $1.30. So in other words, we have 5 sets of negative $1.30. So that's how we're going to write this. 5 times negative $1.30. And then we're going to see what that equals. Since we're not allowed to use calculators, we could add each one of these up individually. You know what? Let's actually do that. Let's just put a line underneath here and let's add these up. 3, 6, 9, 12, 15. So I'm going to carry the 1, put a 5. Let's put the decimal point and a 0 there. And then 1, 2, 3, 4, 5, 6. 650. So that it equals a total of 650. There we go. All right, let's move on to number 8. After 1 minute, a diver is 12 feet below sea level. She continues descending at the same rate. Where is the diver in relation to sea level 4 minutes after she started descending? So we've got the ocean, and then we've got a diver who is descending. Let's try and draw some flippers here. And let's see. Okay. And we've got like a big old scuba tank and some like hoses, some goggles, got some hair, arms. We need arms. Okay, there we go. So we've got a diver. Yes, love my beautiful drawing. Thank you. Thank you. Admire. Okay. And she is descending, and we've got 12 feet every time she's going down, and we've got 4 minutes total. So 12, we go down 12 after the first minute, we go 12 more after the second minute. Oh, I gotta keep going here. We go minus 12 more after the third minute, and finally minus 12 more after the 4th minute. So we have a total of 4 minutes that we've been descending 12 feet each time. So 4 times negative 12, because we're going down 12 each time, and then that's going to equal 4 sets of 12 negative. So we've got negative, and if you can do that in your head, that's fine. If you can't, you can go ahead and write it up here. 4 times 2 is 8, and then 4 times 1 is 4. So that would be 48, and our negative is here, ready to go. And that is our equation. All right, let's go ahead on to number 9. A company has a budget shortage of $54 million. So shortage, that's kind of a word for that means negative, right? We're negative $54 million. Oh my goodness. That's a big budget shortfall. It had to spread the deficit. That's deficit. That's also a negative word. So it's really telling us, whether you know the meaning of one word or the other, that we're talking about a negative. So 54 million is negative. Had to spread the deficit equally among 6 different divisions or departments. By how much did each division need to amend, that means change, its budget. Okay, so 54 million, we're going to divide it by 6 departments. 6 departments. Or divisions. I'm more comfortable with the word department, but division is what it says. It could be either or. If there's a word you're a little bit more familiar with, you can use that. All right, so 54 million is negative, and we're going to divide that by 6 and see what that equals. Right? Because we're taking 54 million that we're short, so we're negative. We're going to divide it by 6 departments. So 54 million divided by 6. So let's do 54 million divided by 6. 6 doesn't go into 5, but 6 does go into 54. Do you know what that is off the top of your head? It's 9. So there's a trick to remembering your 9s. Do you know what the trick is? So the trick is to write the 9s in 2 directions. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 times 1, 9 times 2, times 3, times 4, times 5, times 6, times 7, times 8, times 9, times 10. So 9 times 6, 1, 2, 3, 4, 5, 6 is 54. So this will be 9. That's 54, 0. And then we're just going to bring all those zeros over, because if we brought down the 0, we know 6 times 0 is 0. Then we bring down the other. So 6 times 0 is 0. So we could just kind of save ourselves having to bring down all these zeros and just write them in. So that's 9 million. Every department is short by 9 million. Careful, we're forgetting something. Look. We've got the negative, so a negative divided by a positive is the same as a negative times a positive as far as the negative is concerned. So we need to keep it negative, right? Different signs are negative. Okay, let's do our final problem, number 10. A test has 50 questions, 50 questions. The test will award 5 points when the answer is correct and deduct 2 points when the answer is incorrect. So plus 5 for correct answers, minus 2 for incorrect answers. Okay? A student answered 7 questions incorrectly. What integer represents the number of points that were deducted? So we actually don't even need this information up here. We just need to know -2, and then we need to know 7 questions total. We're wrong. So if we're deducting 2 points for every wrong question, and there's 7 wrong questions, then we're going to say -2 times 7. And 2 times 7 is 14. We've got a negative, so that would be -14. All right. Let me know if you have any questions. Thanks, guys.